Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today we are going to continue with Class 10 Science Part 1, Chapter number 8, Metallurgy. Topics that I am going to cover during this session are chemical properties of non-metals, in which we will see the reaction of non-metals with oxygen, water, dilute acid and hydrogen. We will also learn about ionic compounds and its properties. Non-metals are a collection of elements having less similarity in physical and chemical properties as compared to metals. Non-metals are also called electronegative elements as they form negatively charged ions by accepting electron. So let us see the chemical properties of non-metals. We will start with reaction of non-metal with oxygen. Non-metal react with oxygen to form acidic oxides or neutral oxides. The acidic oxides of the non-metal, they dissolve in water to form acids. Let us see the example. When carbon reacts with oxygen, carbon dioxide is formed. And this carbon dioxide is an acidic oxide. When it reacts with water, the carbonic acid, that is carbon dioxide plus water, it gives carbonic acid. So it forms acid. Reaction of non-metals with water. Generally, non-metals do not react with water. So, in general, we can say non-metal plus water, there is no reaction. For example, sulfur plus water, there is no reaction at all. But there is an exception. Halogens, they react with water. The halogens are a group in the periodic table consisting of 5 chemically related elements, that is fluorine, chlorine, bromine, iodine and astatine. So when chlorine reacts with water, hypochlorous acid is formed along with the hydrochloric acid. Non-metals do not react with acid. Over here you can see when non-metal is reacted with acid, there is no reaction. For example, sulfur, when reacted with hydrochloric acid, there is no reaction at all. Again, here the exceptions are halogens. Chlorine plus potassium bromide, it gives bromine plus potassium chloride. Reaction of non-metals with hydrogen. Non-metals react with hydrogen to form covalent hydrides. For example, hydrogen gas plus sulfur, it gives hydrogen sulfide. And nitrogen gas, when reacts with hydrogen, it gives ammonia. So here the covalent hydrides are formed. What are covalent hydrides? Covalent hydrides means the compound that are formed by sharing of electrons. They have covalent bond between them. Ionic compounds. An ionic compound is a chemical compound in which ions are held together in a lattice structure by ionic bonds. It is formed from two units, namely cation and anion. The cation and anion being oppositely charged, there is an electrostatic force of attraction between them. And we know this force of attraction between the cation and anion is called the ionic bond. Ionic substances are compounds of metals and non-metal. For example, sodium chloride, copper oxide, magnesium sulfide, etc. They are made up of ions, atoms which have lost or gained electrons, giving them a positive or the negative charge. So the atom which loses electron becomes the positively charged ion, that is cation, whereas the atom that will gain the electron will become a negatively charged ion, that is anion. So let us see one example of sodium and chlorine. We know the electronic configuration of sodium is 281. So it has one electron in its outermost shell. So it can easily lose one electron to attain electron octet state, whereas chlorine, the electronic configuration is 287. So it has 7 electrons in the outermost shell. So it can easily gain 1 electron to attain electron octet state. So when it is gaining 1 electron, it will become negatively chloride ion. And we know that positive and negative ions, they strongly attract each other. So because of this strong force of attraction, they form a crystal structure as shown over here in this picture. You can see over here the purple color small balls, they indicate the positive ions, that is the sodium ion, whereas the green color circle indicates the chlorine, negative chloride ion. So in this crystal structure, the positive and the negative ions are held together by the ionic bond, and this compound, that is NaCl, sodium chloride formed, is called an ionic compound. Ionic compounds are crystalline in nature. The surface of all the particles of the crystalline substances, they have a definite shape and are smooth and shiny. The regular arrangement of the ions in the solid ionic compound is responsible for their crystalline nature, and the arrangement of the ions in different ionic compound is different, and therefore the shape of their crystals are also different. Let us see the properties of ionic compounds. The intermolecular force of attraction is very high in the ionic compounds, and large energy is required to overcome it. Therefore, the melting and the boiling point of ionic compound is very high. Most of the ionic compounds are crystalline solids at room temperature. That is, the ions, they are arranged in a regular and geometric pattern. The ionic compounds, they are hard and brittle. The attractive force between the positive and the negative charge ions is very strong, and that is why they exist in solid state and are hard. Also, they are brittle, that is, they can be broken into pieces by applying pressure. The ionic compounds, they cannot conduct electricity when in solid state. In this state, the ions cannot leave their places. However, in the fused or the molten state, they can conduct electricity, as in this state the ions are mobile. The aqueous solution of ionic compounds conduct electricity as they contain the dissociated ions. On passing current through the solution, the ions move to the oppositely charged electrodes. Due to the electrical conductivity in fused and dissolved state, the ionic compounds are also called electrolytes. And the last property of the ionic compound is that they are soluble in water but insoluble in organic solvents like petrol, kerosene, etc. This is because the water molecules orient in a particular manner around the ions separated by dissociation process. As a result of this, a new force of attraction is established between the ions and the surrounding water molecules, replacing the original intermolecular attraction, and the aqueous solution of the ionic compounds are formed. This is the reason that they are soluble in water, but they are insoluble in solvents like petrol and kerosene. This is because, unlike a water, a new attraction force cannot be established in these solvents. This is all for today's session. Thank you so much.